Yeah, exactly. That's all we kind of said at the end, like, wow, what did we just do? Pretty much. All right, let's take a look. So we got our data in. We got L1, shows, L2, commercials. Now we're trying to see if commercials are louder on average than shows. And we have to keep the correspondence, as Michael pointed out, because the commercials are inherently tied to the shows. And this is a slight, you'll see the distinction way more when we start actually looking at data where there are differences in two different data sets. This is actually one data set, the difference between the show and the commercial. So, what do you think we're going to have to do next? We're going to have to subtract them, exactly. So, want to do L1 minus L2? Love it. You could actually go either way, either L1 minus L2 or L2 minus L1. Make sure when you type that in, I still got data in L3, so you got to make sure you go to the top of L3 to type it in. Always remember that, otherwise you get a goofy error. It's not like Excel in that respect. You have to put your blinker on top of L3 to get it to work. All right, L1 minus L2. There we go. Good so far? Boom! All right, here's our data. -2, -1, -3, 0, +2, -3, 2. I see negatives, I see positives, and I see zeros. Why do I see these things? Oh, Michael, go ahead.
0 means there's no difference.
0, no difference.
Negative means the commercial was louder.
Negative means the commercial was louder. Let's make sure we process that. Why does negative mean the commercial was louder?
Because we put the commercials in L2.
Because you put the commercials in L2. So when you did L1 minus L2, if you got a negative number, that means the number here is bigger than the corresponding number here. Positive would mean that the shows are louder than the commercials. Go ahead, Ashley.
Sorry, I'm trying to-
That's okay.
Which commercial? Because there's more than one commercial that plays after a show.
Peak decibel level. That's all this data analyzed, was the peak decibel measured in the series of commercials, if you will, after the show. So we had a chunk of time from the show, peak decibel level there, and then in the commercials that followed, the peak decibel level there, the loudest decibel level.
The funny thing is peak is not a representation of actual.
We'll come back to that. Thank you. We'll come back to that. We'll come back to that. And I have a statistician's apology for that as well. Highly tied to my 5-year-old son. We'll come back to him. Fair enough? I want to look at the data first, if that's okay with you guys. I want to make sure it looks bell-ish shaped, any outliers, things like that, okay? So I'm going to go zoom 9, because I still have my screen set up from before. It's already looking at L3, okay? I apparently don't have any outliers, pretty symmetric data. I'm going to futz with the window, because that's what I do. Actually, I'm not going to futz with it too much. I was maybe half a decibel increments there. Yeah, I'll just leave it the way it was. I'll just use zoom stat, that's fine. Maybe I'll make Ymax a little taller to get the box plot off the histogram. There we go. Pretty mound-shaped, pretty bell-shaped.
Yep.
It's split roughly half and half left to right. Now I do see maybe a little more on the negative side than the positive side. Maybe. And again, I'm going by visual inspection here versus any kind of statistical analysis. So hence why we're doing the test. So let's set up a test. Let's answer the question statistically, whether or not commercials are louder than the shows they follow. What's going to be in the null? That the average difference,
0.
there is none, exactly, that is 0. Now remember, we're trying to see if the commercials are louder than the shows. So, okay, good, I'm hearing a little bit of dissension here, this is good. Good, there's good dissension going on. We know this has to be a 0 because it has to match what's in the null. We know that. Now hang on. Well, you can leave the equals to sign off as far as what, the equal sign is going to be basically going up here. If commercials are louder, that's what this is going to tell us, right? Commercials are louder than the shows. What kind of numbers are we going to be getting on average? Negative, so it's going to have to be a less than sign, isn't it? Based on how we subtracted. We did show minus commercial. So if the commercials are indeed louder on average, we should be getting on average negative numbers, which means we're going to get less than 0 on average. Could you run the test by subtracting L2 minus L1 and then put a positive value?
Yeah.
Of course you could. You get the exact, we'll run it actually when we're done. We'll turn the test around and run it both ways and you'll see you get the same result, except for the sign of your test statistic. That's the only difference. Okay? And the reason I bring this up is based on our discussion about less thans and greater thans last time. I think that's still confusing a couple people. And we'll make sure we get that squared away. We're still going to have a t-test statistic. Let's see what that test statistic is. T-test. We got data. We're testing against 0. This is all the same. There's no difference there. The only difference is here. Which sign you're going to test. So we're testing less than.
The one in the middle.
Say that again?
The one in the middle.
The one in the middle, exactly. And that's, again, why I have you write the hypotheses down. I have you write the hypotheses down because I want you to just be able to take that and translate it over to the inputs in your TI. Shouldn't be any confusion. All right, let's do it. Nope. Yeah, well, that's okay. We'll turn that off later. That's your box plot, your histogram. Holy area! Being scary over there. All right, friends. Lots of area. Test statistic about negative 1.09. Sure, negative 1.1. Anything you want. P-value 14%-ish. Ish. But the big news is that what?
No.
There's no statistically significant difference. Are they louder?
Yes.
Are they louder? Yes, they are. You can tell because
P-value.
the test statistic is negative, which implies that on average there was a negative value. But it's not far enough negative to go, now we're outside of that 2 standard deviations realm. Go ahead, Michael.
Can't you say on average, given the p-value, that they're 14% louder?
You can't do that. That's a great question. That's a great question. Michael's question is, look at the p-value, it's 14%. Can't you say they're 14% louder? You could say that. You just shouldn't say that. And here's why. If you run the sample again, assuming there is no difference, you'll get a different p-value because you'll get different sample values. The p-value is a measure of agreement of your data to the null hypothesis. It's not a measurable value. You have to actually construct a confidence interval, if you will. We could do this if this was one-sided, which we don't have a one-sided interval. That would actually give you the idea of percentage louderness. But the problem is there isn't percentage louderness. That's the problem. There is no loudness actually because it doesn't appear that they're louder. Louder, but I think that's not, as Zoe said, statistically significantly louder. Fair? Go ahead, Christian.
Why is it not again? Like what your p-value is larger than 5%?
Too big. Too big. We're still within this guy's confidence interval.
Status quo.
Yep, we're still perfectly said. We're still within the status quo H naught, nothing's changed. There's no reason to believe they're any louder. Fair enough? Now, I want to re-answer when I asked what sign should go here. Some of you said greater than. You can put a greater than sign here. You can. But you have to subtract your data the other way. This is the problem with subtraction. It's not commutative. You get different results when you subtract numbers in different ways. Watch this. Watch this. Stat, edit. Okay, here's L1 and L2. In L3, now what I'll do is I'll do L2 minus L1. Now watch the signs when I press enter. They all swapped. The negatives have now become positive, the positives have now become negative, which means if the commercials are louder, we'll now have an overly positive value because we did commercial minus show. And if commercials are louder than the show, we'll get larger positive numbers. So all you got to do is run the test now on this sign. Now watch this. Watch this. God damn it, the graphs are still on, apologies. How are they similar results and how are they different results? How are the results similar and how are they different? Christian?
Well, it's the same graph, just flipped.
It's the same graph flipped. This was our old graph with a negative 1.09 test statistic. Here's our new graph with a positive 1.09 test statistic. There's no difference. There's no difference. What's exactly the same?
P-value.
No difference whatsoever because it's the same level of significance. Whether you look at commercial minus show or show minus commercial, the relative magnitude of the numbers is exactly the same. There's no difference at all. So your choice about how you choose to analyze it, it's up to you. It's up to you. Some students, I only say this anecdotally, half of the students in 244 will always go L1 minus L2. And then just make sure they know which sign they have to put in. And the other half will always do biggest minus smallest. And just make sure they understand the context. Does that make sense? So they'll identify, what research question am I asking you to do? Okay, commercials are louder than the shows. That means I've got to do L2 minus L1 because commercials are in L2. It's up to you, and you'll get the feel for it the more you do it. Yes, Susie?
Okay, I'm sorry. So on like the one you have,
Yeah.
mu difference.
Mm-hmm. is the difference between the volumes of the TV shows and the commercial. It's both. It's both together.
Yeah.
It's
I
both
got that.
together.
I'm sorry, I'm still trying to figure out when you do less than or more than.
That is something that you're all going to have to come to peace with on your own. And there's no good answer for any individual person because every person's going to approach it differently. You have to know what I'm asking you to do. Am I asking you to compare a show to a commercial or a commercial to a show? It's up to you. You could do it either way, but the sign is going to be governed by how you choose to do the subtraction. So I'll be looking in this step for either a positive or a negative. It's not so much that I care about whether it's positive or negative, it's whether I care about if you got the relative size correct. 1.09 standard deviations up or down are both correct as long as you got the relative magnitude in the right direction. Yeah, exactly. And this is something you'll make peace with. You'll make peace with as you look at different data sets. It's just a matter of understanding. This right here, knowing which sign to pick here is just one of those things you have to come to peace with on your own. And you will. You will. I've tried to teach all the different methods every single term, and it doesn't work. It doesn't work. It comes up to the student just being able to pick what they're comfortable with. Like I said, half students just go put L1 minus L2, boom, and then just realize what kind of number you're going to have. Yeah, Jared.
On a test, if we draw a blank, can we just do negative 1.09 or 1.09?
That's not drawing a blank. That means you got the sign correct, as long as the p-value agrees with the sign.
Got it.
I don't care which one of these you have, as long as your p-value is going the right way. The problem you would have is if you had, and yes, you could absolutely do that. The problem is if you had that and you had 86%, I'd be like, oh, they went the wrong way. So yeah, it doesn't matter to me which one you put. That doesn't matter to me whatsoever. Or on quizzes or anything else for that matter. Now, what's interesting about this surprised me. Because what does this say about our claim? That they're not significantly louder. So I did a little research. And I found this. A little research. This is from the British Advisory Standards Authority. Right, dude. So, anybody play guitar? Play guitar? We got a couple of no guitar players. In the studio, there's an effect called compression. When people are playing guitar, or any instrument for that matter, or even vocal compression, the idea of compression is to make sure that a sound frequency level never drops below a certain level. So it's audible. So when people are playing the guitar, for example, to make sure that every downstroke is basically essentially the same intensity level, so you don't hear like intermittent kind of stuttering or stammering guitar work. They use compression on vocal tracks, if you will, or effects tracks for commercials too, which I didn't realize. So what they do is you've got your show volumes down here in blue. What they do is they take those compressions and boom, boost them as a percentage of the input level. But they set what's that word? They set the peak. There's another word I'm forgetting now from studio work. But yeah, they set the peak so that it can't exceed this, which means that the highest possible value of the normal show won't exceed the highest possible value of the commercial. So that's why I don't want to just look at the peak decibel levels. I want to look at the overall decibel levels, not just the peak. That's what Mike brought up earlier. If you're only looking at peaks, you're maybe getting a skewed look at overall volumes. Because what you guys were saying is I have to turn the volume up, or down, I should say, to have a conversation with my friend during a commercial. This doesn't necessarily answer that question. The only data I could find, it only answers the peak decibel levels. I would collect the data myself, but this is where I blame Max. I don't actually have the time to do that. So I've been looking for a study out there. I would hope that the Senate would actually do this. I hoped that for about 3.5 seconds, so I realized that they wouldn't. They would just shoot from the hip like they always do. Yeah, Susie.
Although the graph, it kind of explains our data because it means that at the peak, there's no difference.
There's no difference at the peak.
But
Exactly.
the rest of it,
There is a difference, and the differences get larger the more quiet the values are. Exactly, and that's the trick. That's what I want to look at as other data, not just randomly selected every 5 seconds through the course of 30 commercials, and have a data set with hundreds, if not thousands, of data points, and then use Excel to crunch it or something like that to crunch it. But we'll get around to that. Fair? Puberty, it's a bitch. Cool. Now,